Hello friends, today's topic of discussion is conversion of WCB to RB and vice versa. Before starting actual conversion, we'll see what are the methods available for calculating of bearings. So there are two types of bearings. First is your whole circle bearing. The system of bearing is known as whole circle bearing. The short form is WCB. And second is your quadrilateral bearing. The short form is your QB. We can write it as QB. So in this figure, here we can see. So what is whole circle bearing? Whole circle bearing is nothing but the bearing which is calculated by using prismatic compass. So in prismatic compass, we can calculate whole circle bearing starting from 0 degree to 360 degree. So minimum we can calculate 0 degree and maximum we can calculate 359 degree 59 seconds minutes, which is nothing but your 360 degree. By using prismatic compass, we can calculate whole circle bearing. In whole circle bearing, we can calculate minimum 0 degree and maximum 360 degree. So, for example, we have to calculate bearing of point A with respect to O. So, in prismatic compass, as we know, we have to mark north line. So, with respect to your true north or magnetic north, the angle measured between OA is known as bearing, and it is known as whole circle bearing because it is calculated by using your prismatic compass. Likewise, if we are calculating bearing of B, then it will be 135 degree as it is in second quadrant. Likewise, we are calculating bearing of C, which can see here 265 degree 36 minutes 20 seconds, and likewise we have find out the bearing of D, which is 328 degree. So we can find out the bearing of any point with respect to north in a clockwise direction from 0 to 360 degree is known as your whole circle bearing. Moving on to second part, which is quadrilateral bearing. In quadrilateral bearing, circle is divided into 4 quadrants. Over here, as we can see, first quadrant is northeast, second is your southeast, then southwest, third quadrant, and fourth quadrant is our northwest. So in quadrilateral bearing system, we can calculate bearing from north or south direction, whichever is closer towards east or towards west. So in this system, we'll get minimum 0 degree and maximum 90 degree. So we'll get whether your line is in first quadrant, second quadrant, third quadrant or fourth quadrant. Accordingly, we'll name it. For giving a simple example, if your A lies in northeast, we'll calculate angle with respect to north direction because it is nearest, and we'll denote it as north 40 degree east. Means what? We are calculating line or bearing with respect to north towards east 40 degree. Same if it is in fourth quadrant and we are calculating the bearing towards west, so we will write north 40 degree west. So we have to focus on quadrants over here in quadrilateral bearing. Moving on to the next part, in detail, what is whole circle bearing? So the bearing of line measured with respect to magnetic meridian or magnetic north in a clockwise direction is known as magnetic bearing, and its value varies from 0 to 60 degree. And the clockwise word is very important here. Next, the quadrant starts from north and progress in a clockwise direction, as the first quadrant will read 0 to 90 degree, Second quadrant 0 to 180 degree. Third quadrant 180 to 270 degree. And fourth quadrant again 270 to 360 degree. So whole circle bearing is divided into 360 degree. While talking about quadrantal bearing, in this system the bearing of survey lines are measured with respect to north line or south line, whichever is nearest to your given survey line, and either in the clockwise direction or anti-clockwise direction. So in quadrantal bearing we can calculate angle with respect to north or south in clockwise direction as well as in anti-clockwise direction, depend upon the position of your line. Now talking about the reduced bearing, we have heard this term also, reduced bearing. What is reduced bearing? Reduced bearing is nothing but it is when we convert whole circle bearing into quadrantal bearing, the term is known as reduced bearing. So don't get confused between quadrantal bearing and reduced bearing. It is nothing but the conversion of whole circle bearing into quadrantal bearing, that is known as your reduced bearing. So it is similar to your quadrantal bearing only. Thus it has the values lies between 0 to 90 degree, but the quadrant should be mentioned for proper designation. If I can give you one example, you have written 40 degree. In reduced bearing I have written 40 degree only. Now as we know, in reduced bearing there are 4 quadrants. So 40 degree in which quadrant? How will you identify? When we write north 40 degree east, it means it is in first quadrant. So the mention of your quadrant is very important here. Now we'll see what are the conversions used for reduced bearing from your whole circle bearing. So over here, if we can see, we are in first quadrant. So in first quadrant of WCB, reading vary from 0 degree to 90 degree. It is known as your first quadrant. For conversion RB to WCB, so RB will equal to WCB because of first quadrant, and the quadrant will be your north east. Second rule lies for second quadrant, 90 degree to 180 degree. If your whole circle bearing is between 90 degree to 180 degree, then the rule we are using is RB is equal to 180 minus WCB. For your better understanding, if the whole circle bearing of this line is given and we have to find out is RB. So RB will calculate with respect to south line because south is nearest. So total is 180 and subtracting WCB will get what? RB. So from 180 we have to subtract WCB to get RB. This rule is written over here. For your third quadrant, in third quadrant we have to calculate RB. Now again it is nearest to your south. How will we calculate? We know the WCB and we know this is 180 degree. To get RB, what we have to do? We have to subtract 180 from your WCB, and the quadrant will be third quadrant and will denote it as SW. In fourth quadrant, last quadrant, if my line lies in fourth quadrant, we know the WCB reading. As we know, the complete circle is of 360 degree and this line is nearest to your north. Then how will we find out this? Total angle 360 degree minus your WCB. So we will get RB over here and the quadrant will be northwest. So this table we have to keep in mind while we are converting WCB to RB. Talking about the conversion of your RB to WCB. Now we are doing vice versa. We are converting RB to WCB. So RB will be given in quadrantal from, for example, first is northeast. Now northeast, as we know, northeast will lie in first quadrant. So keep in mind, whenever first quadrant is here, WCB is always equal to RB and RB is equal to your WCB. So angle will be between 0 to 90 degree. Then for second quadrant, which is south east, now we have to convert RB to WCB. RB we have to convert into WCB. How will you convert it? Total we know, total is 180 degrees. So from 180 we have to subtract this angle to take our WCB. So 180 degree minus RB, and the angle will lies between 90 to 180 degree. Next is third quadrant, which is south west quadrant. Now angle is from south towards west, and we have to find out complete bearing from your north line. How will you find out? As we know, this half portion is 180 degree. So your RB plus 180 degree to get complete whole circle bearing, and the angle will lies between 180 degree to 270 degrees. Moving on to last portion, fourth quadrant. In fourth quadrant we calculate angle with respect to north. Now we have to find out this angle WCB. How will you find out? So total is 360 subtracted by your RB will give your remaining angle, which is nothing but your WCB. So WCB will be 360 degree minus RB, and the angle will lie between 270 degree to 360 degrees. So this rule we have to keep in mind while converting RB to WCB. So either one table we have to keep in mind to convert WCB to RB or RB to WCB. Now we'll see what are the examples of converting WCB to RB. So moving on to the first example. So we are given 49 degree and we have to convert this 49 degree to RB. Now how will you identify whether it is a WCB or RB? Whenever angle is written alone without any quadrant, it means it is in WCB only. So now we have to convert our WCB 49 degree to RB. The very first step is to identify the angle lies in which quadrant. So the angle lies in first quadrant, as we can see in this figure. 49 degree lies in first quadrant. So what is the rule? Rule says in first quadrant WCB is equal to RB or RB is equal to WCB. So RB will be 49 degree only, angle is 49 only, but here we have to write quadrant. So first quadrant is nothing but your north east quadrant. So the RB will be in northeast direction. So we have to write down north 45 degree east. Therefore RB will be what? North 49 degree east. Second example, we have to convert 240 degree into RB. Now how will you convert 240 degree into RB? So we have drawn figure over here for your reference. So as we can see, the total angle is 240 degree WCB. So 240 degree lies in third quadrant. So first of all we have to mark it is lies in third quadrant, and third quadrant is nothing but what? Is south west, from south towards west. Now whole circle bearing is given. Whole circle bearing total is 240 and we have to find out this angle, southwest angle. How will you find out? The RB is equal to WCB, the whole circle bearing, minus this angle, which is nothing but 180 degree. So we have to subtract 180 degree. So this will give us 240 degree minus 180 degree, which is 60 degree. Angle is 60 degree and the quadrant is third quadrant, which is southwest quadrant. So the answer will be south 60 degree west. Hope you are understanding these simple parts. Moving on to next example. Now we have to convert 335 degree into radius bearing. Whenever you heard 335 degree, so if you can recall the graduated part, 0 to 90 is first quadrant, 90 to 180 second, 180 to 270 third quadrant, and 270 to 360 degrees fourth quadrant. So it will lie in fourth quadrant. So over here we have drawn a figure. So we have given a whole circle bearing total of 335 degree. We have to find out angle between north and west because it's lied in fourth quadrant. How will you find out? What was the rule? RB is equal to, for fourth quadrant, total 360 degree minus WCB. So 360 degree minus WCB is 335 degree. Will give the angle 25 degree, but it is reduced bearing, so we have to mention quadrant also, and the quadrant is fourth quadrant, which is northwest. Likewise, we can find out any bearing or convert any whole circle bearing to reduced bearing by using simple formula. For example, if we have to convert 140 degree into RB, how will you convert? We'll draw a figure. This is my 140 degree. These are my quadrants. Now how will you convert WCB to RB? It lies in second quadrant. So what was the rule for second quadrant? RB is equal to total 180 degree north to south minus your WCB, which gives us angle south east. So RB will be in this case 40 degree south towards east. So likewise, you can take up any angle and convert it into RB. You have to be careful while writing down the quadrants. Now we'll see the conversion of RB to WCB. The very first example, we have to convert north 60 degree, 65 degree east to your WCB. How will you convert? North east. (65 degrees) given. So it lies in first quadrant and it is written as northeast. The first rule says for first quadrant, RB is equal to WCB and WCB is equal to RB. So directly we can convert this reading into WCB. Right? Now moving on to second problem. Now it is written as south 43 degree 15 minutes towards east. Am I drawing it right? No. So it will rise in second quadrant. Exactly. on southeast. This angle is 43 degree 15 minutes, and we have to find out WCB. So as per the rule, if it lies in second quadrant, WCB equal to what? Total angle, which is 180 degree minus your RB. Will give us the answer 136 degree 45 minutes. Likewise, if we have to find out any other angles, for example, south 30 degree west. Now how will you convert it? Southwest. So southwest lies in third quadrant. First of all, we have to mark the quadrant. This angle is given. We have to calculate whole circle bearing. So we have to calculate complete angle. How will you calculate? WCB is equal to, we know this angle, which is 180 degree plus towards west. So we have to add this angle. So plus your RB. Which gives us the total angle of 210 degree. So we have to be careful while finding out the quadrants. We'll take up one more example. It is given north 40 degree west. So as we see northwest, it means it is a fourth quadrant. So while finding out WCB, what rule says? As we know, the total bearing is 360 degree, and we have to subtract bearing of N west, northwest. The answer will be 320 degree. So depend upon the angles and depend upon quadrant in which they are lying, we can easily convert WCB to RB. Likewise, we can convert RB to WCB. Thank you.